NEC Article 300.12 states that electrical equipment shall be installed in a neat and workmanlike manner. This essentially means that all electrical wiring and equipment needs to be installed in a way that ensures safety, organization, and visual appeal. NEC Article 404.10b addresses conductors passing through control cabinets, stipulating that they must be identified for the specific system or circuit they serve. Clear labeling is crucial, making it easy to discern the purpose of each conductor within the cabinet. Combining these two articles reveals that the NEC doesn't explicitly forbid using a control cabinet as a pull box. However, it does emphasize the importance of a neat and workmanlike installation for all electrical equipment, along with clear labeling of all conductors. Considering the specific scenario, the electrician's concern likely stems from the potential difficulty in identifying the purpose of conductors if the control cabinet is used as a pull box. This could indeed pose a safety hazard, especially if a technician works on the cabinet in the future and struggles to determine the function of each conductor. To mitigate this concern, consider using a separate pull box to house the conductors that aren't part of the control cabinet's primary function. This would simplify conductor identification and help maintain a neat and workmanlike installation within the control cabinet itself. When interpreting and applying the NEC, always refer to the latest edition of the code, as requirements can change with each update. Also, consult with a qualified electrical inspector or engineer to ensure compliance with local codes and regulations, as interpretations may vary. Now, let's delve deeper into the implications of Article 300.12 regarding neat and workmanlike installations. This goes beyond mere aesthetics. It's about ensuring the long-term reliability and safety of the electrical system. Disorganized wiring can lead to several problems, including difficulty in troubleshooting, increased risk of accidental damage, and potential for overheating due to restricted airflow. A neat and organized installation makes it easier to trace circuits, identify components, and perform maintenance or repairs. Consider the layout of conductors within the control cabinet. Are they bundled and secured properly? Are there sharp bends or kinks that could damage the insulation? Is there sufficient space around components for ventilation and access? These are all factors that contribute to a neat and workmanlike installation. Article 404.10b's requirement for conductor identification is equally crucial. Without proper labeling, it's virtually impossible to determine the purpose of a conductor without tracing it back to its source, which can be time-consuming and potentially hazardous. The NEC doesn't specify a particular method for identifying conductors, but it does require that the identification be clear and durable. Common methods include using wire markers, labels, or color coding. The choice of method depends on the specific application and the environmental conditions. For example, in a harsh environment, you might need to use wire markers that are resistant to chemicals, moisture, and abrasion. When labeling conductors, be sure to include information that is relevant to the system or circuit they serve. This might include the circuit number, voltage, phase, or function. The more information you provide, the easier it will be for someone to understand the purpose of the conductor. Now let's explore some alternative solutions to using the control cabinet as a pull box. One option, as mentioned earlier, is to install a separate pull box. This is a simple and effective way to isolate the conductors that are not part of the control cabinet's primary function. The pull box should be sized appropriately to accommodate the number and size of conductors, and it should be installed in a location that is easily accessible for maintenance and repairs. Another option is to use raceway or conduit to route the conductors to their destination. This provides physical protection for the conductors and helps to keep them organized. Raceway and conduit are available in a variety of materials and sizes, so you can choose the one that is best suited for the application. If you are using raceway or conduit, be sure to follow the NEC requirements for full capacity and bending radius. Overfilling a raceway or conduit can damage the conductors and make it difficult to pull them through. Sharp bends can also damage the insulation and reduce the ampacity of the conductors. A third option is to use a cable tray system. Cable trays are typically used for large installations with many conductors. They provide a flexible and efficient way to route and support cables. Cable trays are available in a variety of materials and configurations, so you can choose the one that is best suited for the application. If you are using a cable tray system, be sure to follow the manufacturer's instructions for installation and support. In addition to these physical solutions, there are also some administrative measures you can take to improve the safety and organization of your electrical system. One is to develop a comprehensive labeling system for all conductors and equipment. This system should be documented and readily available to anyone who needs to work on the system. Another is to provide training to all personnel who work on the electrical system. This training should cover the NEC requirements for safe installation and maintenance practices. By taking these steps, you can help to ensure that your electrical system is safe, reliable, and easy to maintain. Remember that the NEC is a living document that is constantly being updated to reflect new technologies and best practices. It is important to stay up to date on the latest changes to the code and to consult with a qualified electrical professional when you have questions or concerns. In any electrical work, safety should always be the top priority. Always to energize circuits before working on them and use appropriate personal protective equipment, such as gloves and safety glasses. By following these guidelines, you can help to prevent accidents and injuries. Now let's specifically discuss scenarios involving a 240/120 volts alternating current, single-phase lighting panel, and the implications for passing circuits through a control cabinet. In this context, it's even more crucial to ensure proper identification and segregation of conductors. Because lighting circuits often involve complex switching and control schemes, misidentification can lead to significant problems. Firstly, consider the potential for voltage differences within the control cabinet. You might have 120 volts alternating current circuits for lighting control alongside other low voltage direct current circuits for sensors or automation. Mixing these without clear separation and identification can create a shock hazard. Secondly, the NEC requires specific overcurrent protection for lighting circuits. Ensure that the conductors passing through the control cabinet are adequately protected by circuit breakers or fuses in the lighting panel. The ampacity of the conductors must also be sufficient for the load they serve. Thirdly, pay close attention to grounding and bonding requirements. The control cabinet itself should be properly grounded, and all metallic components should be bonded together to minimize the risk of electrical shock. Fourthly, consider the impact of electromagnetic interference, EMI. Lighting circuits, especially those with electronic ballasts or LED drivers, can generate EMI that can interfere with sensitive control circuits. Shielding the conductors or using filters may be necessary to mitigate EMI. Fifthly, ensure that the control cabinet is adequately ventilated to prevent overheating. Lighting circuits can generate heat, especially if they are heavily loaded. Overheating can damage conductors and components and potentially create a fire hazard. Sixthly, if the control cabinet is located in a damp or wet location, use conductors and components that are rated for wet environments. Water can cause corrosion and short circuits. Seventhly, always use approved wiring methods. The NEC specifies the types of wiring methods that are permitted for different applications. Using unapproved wiring methods can create a safety hazard. Eighthly, double-check all connections to ensure that they are tight and secure. Loose connections can cause arcing and overheating. Ninthly, before energizing the circuit, thoroughly inspect the installation to ensure that everything is properly connected and grounded. Tenthly, after energizing the circuit, test the operation of all lighting fixtures and control devices to ensure that they are functioning correctly. By paying attention to these details, you can ensure that your 240/120 volts alternating current single-phase lighting circuits are installed safely and reliably, even when they pass through a control cabinet. Always remember to consult the NEC and local codes for specific requirements and to seek the advice of a qualified electrical professional when you have questions or concerns. It's also important to note that the specific requirements for control cabinets can vary depending on their application and location. For example, a control cabinet located in a hazardous location, such as a chemical plant, will have more stringent requirements than a control cabinet located in a general-purpose area. Be sure to consult the NEC and other applicable standards for specific requirements. Furthermore, when dealing with control cabinets that are part of a larger system, such as a building automation system, it's important to consider the overall system design and integration. The control cabinet should be designed to work seamlessly with the other components of the system, and all wiring and connections should be properly documented. In addition to the NEC, there are other standards and guidelines that may be relevant to control cabinet installations. These include standards from organizations such as the National Electrical Manufacturers Association (NEMA) and the International Electrotechnical Commission (IC). These standards provide guidance on topics such as control cabinet construction, wiring practices, and testing procedures. When designing and installing control cabinets, it's also important to consider the long-term maintainability of the system. The control cabinet should be designed to be easily accessible for maintenance and repairs, and all components should be readily replaceable. Proper documentation, including wiring diagrams and component lists, is essential for facilitating maintenance and troubleshooting. In conclusion, while the NEC doesn't explicitly prohibit using a control cabinet as a pull box, it emphasizes the importance of neat and workmanlike installations, clear conductor identification, and overall safety. By carefully considering these factors and following the guidelines outlined in the NEC and other applicable standards, you can ensure that your control cabinet installations are safe, reliable, and easy to maintain. Always prioritize safety and consult with qualified professionals when in doubt. Remember to stay informed about the latest changes to the NEC and other relevant standards, as these codes and guidelines are constantly evolving to reflect new technologies and best practices. Continuing education and professional development are essential for staying up to date in the ever-changing field of electrical engineering. By embracing a commitment to lifelong learning, you can ensure that you are always providing the highest quality of electrical services.